water and consuming water, we have to think about the contaminants in the water. Do we want to put things into our body that shouldn't be there, like heavy metals, pesticides, chemicals, drugs, all kinds of things like this? They are in the water. If you think about where your house is, if you're on a well, for instance, and anyone sprays pesticides in their yard or on a farm within a 300-mile radius, those pesticides get in the groundwater and into your well. Imagine that for a minute. Pesticides sprayed on a farm 300 miles away could end up in your drinking water. So this is a problem. We need to filter water. We need to remove the contaminants that shouldn't be there in the first place, so that we don't have to, by our organs, our kidneys, our liver, our other organs, we don't have to eliminate them. We don't have to filter them out inside our body. Let's do that before it gets to our body. Let's filter the water before we drink it. This is the appropriate thing that we should be doing. So what are the different types of filtration methods? First of all, we have media. We can use what's called granulated carbon, for instance, or any granulated media means that it's like sand, kind of. And so as you run water through it, those media do what they do. So let's talk about carbon for a minute. Carbon can come from different sources. The best is coconut husks. So when you take coconut husks and turn it into carbon material, what's called activated carbon, this is one of the most effective medias for filtration for organic materials in water. And so media simply is another way to say you're running water through a substance like carbon or other types of things, and when the water goes through it, there's a reaction that occurs, and the contaminants react and change to something else, like chlorine would change to chlorides, for instance. But there's other things like a water softener that literally has an ion exchange. So in a water softener, yes, there's a media and the water goes through it, but that media has a charge to it. We call them resins many times. They'll have a charge to them so that when the water passes through and heavy metals or what's called total dissolved solids, whether they be minerals or what have you, they'll be attracted to the resin. And there's almost like an exchange. I'll take your heavy metal and I'll give you a salt molecule. That's how they work. So there's a swap, a salt or potassium molecule for every molecule or hardness for minerals or heavy metals or what have you. That's how a water softening system works. And again, you can use salt or potassium as your exchange material. Now you have reverse osmosis. Reverse osmosis, if you can imagine a garden hose and you poke the tiniest little holes in it and you force water through the outside of the hose into the inside of the hose, and then you allow that water to run through, that's in effect how reverse osmosis works. It's a membrane and the holes are so tiny, you're pushing them through at a pressure, and so everything else stays behind that's larger than the hole size. And that's the way the purification happens. Everything, for the most part, except for pure water, stays behind and doesn't go through the hole. This is the main types. We also have distillation, or what's called a distiller, a water distiller. This is done, and the whole purpose of this was to mimic the earth in a way where you have evaporation of water and then it phase changes or phase shifts back to a liquid. Well, this is what a distiller does. It boils the water, and it's like a U. You have a venturi, and so on this side, you heat the water up to a boiling point. Water then evaporates, turns to a gas, goes up and over, and it cools and turns back into a liquid and comes down the other side. And the theory is when it phase shifts, all of the stuff that you don't want in the water stays behind. Well, this works extremely well for total dissolved solids, minerals, heavy metals, things that are solid materials. But it sometimes doesn't work for other things like gases or chemicals that can also phase shift with the water. And so it's not perfect. Nothing is perfect, but it's not a perfect method to get pure water, but it's a very good option. I would say media is an excellent way to filter water without losing your minerals. That's the reason you would use a media, to remove contaminants but keep the minerals in the water. Reverse osmosis is a way to clean water of both total dissolved solids and contaminants and minerals in the water, so that you just have water left. And then again, distilled water is very similar to reverse osmosis, but it takes a long time to produce water. So the most effective methods of filtration would either be media or reverse osmosis, or a combination of the two. And inexpensive for a whole house system to remove your total dissolved solids would be a softener. So these are the different reasons you would use the different types of filtration. We, of course, in our machines, in the Echo machines, have media that removes contaminants but does not remove the minerals. We also have our Echo RO system that's an on-demand reverse osmosis, what's called a tankless reverse osmosis system, so that you can have extremely clean water but not have to wait, because it will produce 1.2 liters a minute of reverse osmosis water. Those are the two types of system that we have. Media, which is in the filters in our water machines, and we have a whole house filtration system. And then we also have reverse osmosis, the Echo RO system, that is an on-demand reverse osmosis system that goes under your sink in your kitchen. These are the systems we have, and this is also a general overview of filtration mechanisms.